Yes.
Hi. So we are going to talk about alternative least square means. So what is this basically is it is a recommendation engine. So why do we
Mm-hmm.
need a recommendation engine? Okay. So
Mm-hmm.
we need all big things in our life. We only go through a recommendation. That's what we call as word of mouth. For example, which college you need to join, who is a good tutor, uh, what is a good coaching class, and even in case of marriage or anything, the
Mm-hmm.
best example is home.
Mm-hmm.
Which area to buy home? Okay, um, what is a good schooling district?
Mm-hmm.
How the schools, even though there are so many websites that tell you about schooling district and all those, you still talk to your friends
Yeah,
and
yeah, correct.
people
Mm.
to find out that okay, this particular schooling district is good, or you talk to people. Basically, human being is a social animal. We
Mm.
talk to our people. We find, if five people say, hey, five people who we trust say that okay, XYZ is a good movie, we
Mm.
go to that movie.
Correct.
So what is the basic concept here is we try to talk to people who are like minded like us,
Mm.
and who do the things same like us, and we talk to them, and we use the same knowledge to buy more. So
Correct.
based on that, there is something called Pearson coefficient uh,
Mm.
that is there. So let me.
Mm-hmm.
So what we do in this is there are like three steps. Assign a weight to all you. So for example, you are trying to build a system
Mm.
uh, model in such a way that you want to sell all your products, right?
Mm-hmm.
Everybody wants to sell their own products, come out with a list of things. So what we'll do is who are all there are two kinds of um, uh, ways to do that. One is
Mm-hmm.
find the demography of the person,
Mm-hmm.
then say okay, all the items that a particular person has bought, the same
Mm-hmm.
demography person can buy the similar item.
Mm.
So if Ravi and me are same demography, so
Mm-hmm.
if Ravi has bought incense stick, then I'll
Mm.
also buy incense stick. That is the kind of thing that.
Correlation in a way, right? It
Huh,
is.
based on the demography or based on some user characteristics. We can't,
Mm.
demography could be one,
Mm.
uh, salary could be one,
Mm.
the area could be one. So like that, you
Mm-hmm.
can have. So all these are called dimensions, right? Area,
Mm.
demography,
Mm.
the age, the
Mm.
salary,
Mm.
the um, likes and shares and all those.
Mm.
That they are called dimensions of the users.
Mm.
So there is another model which says
Mm.
that okay, user Ravi has
Mm.
bought items A to say 1 to 10 items user
Mm.
Ravi has bought,
Mm.
and user Ravi is saying that out of 3, 5, 7, 9 are better,
Mm.
and 1, 3, 1, 2, 4 are not so better. 10
Mm.
is excellent. So
Mm.
like that, Ravi has mentioned. So like
Mm.
Ravi, some John has come, and
Mm.
John also has given same rating, and
Mm.
so has Stella come, or the ratings of the items have been
Mm.
similar between John, Ravi, Stella, Mary, all those people.
Mm.
Here, the user demography is changed now.
Correct.
So we are no longer seeing that, hey, is the user same as Ravi? Is
Mm.
Stella same as Ravi? Yes or
Mm.
no? We don't know. So
Mm.
like that, like
Mm.
Mary, Stella, or John. So
Mm.
all of them have the similar kind of rating.
Mm.
Meaning, if Prakash has come, who has you has given similar rating for 135, there is a heavy possibility that Prakash can also buy 6. Prakash has not yet bought 6, but there is a heavy possibility that Prakash can buy 6. Here, I mean, 6 is the product, item 6. So, you are seeing, this is basically telling that you are giving weight to all the users. Will Prakash be more likely to buy what Stella has bought, or will Prakash be more likely to buy what Ravi has done? So this is the Pearson's coefficient.
Yeah, man, but
Very
that looks like a Greek and Latin term,
very
right?
mathematical, but it's actually very simple. Okay. So this is telling you that it is an average rating that a user has.
RA is like an average rating. Okay.
RA over a bar is the average rating that say a user A,
Of that product. Okay.
user A has given for a average out of 10 items. What is the average rating the user has given for each item? Combine the rating
Oh, I see.
and divide
Gotcha.
by number of items. So that is a simple average. Now,
So that is just one number, right? Then RA is just one number based on the 10
everything is a
products.
number.
What is the average? Yeah, gotcha.
Is a
Yeah.
number.
RA is a okay, gotcha.
So let me show the data here. Okay. See, if you see here, user 0 has looked at item 2 and he has given a rating of 3. Okay, this is lambda. Okay, so they only figure out only on these 3. Okay,
so in this case, user has item 2, 3, 5, 9, and all the zeros, right? I think
so
there
is
are
the user
49 samples, right, of user.
0 is the user. Okay, for
Gotcha.
0 user, we have this rating. Okay, and for 1 user, we have this rating.
Yeah.
Okay, the items are repeating. You see this one 3, 1, 2, 4, 1, 1, 1, 1, 1, 1.
Correct.
Okay, so
that is rating he is repeating, right? Item is your second column, right?
Item is second column. The rating
he has I think he bought
5.
like 50 items or something, and each item he gave a rating, right? So that's how it is.
Correct.
Okay.
So these are the items. The second column is the items. So if you see, the user 1 has not bought the same items as.
Gotcha.
There is some similarity, intersection is. The similar case with user 3 and user 2, like that.
Correct.
Okay.
So the lambda portion you are ignoring right now, Prakash, like 1, 4, 2, 4. Okay, gotcha.
Right. So this one. Okay. Actually, let me. What I did was I just took these ratings. Okay. Let me see if there is going to be something else of this movie. If 0 to, I did a simple Google search on the thing, so it gave me everything like a Scala example. Okay, collaborative functioning. Lot of Chinese people are taking ML and AI very seriously.
Yeah, man.
And
they are second best in terms of colleges and all, right? Chinese. So obviously you find them more into this.
They are embedding AI and ML into everything. And we are still only thinking about Spring, Hibernate.
Yeah.
All the stuff. Okay. That apart. So now we have this thing. Where are we going?
Yeah, now you have got that formula, right? Let us put that in that formula.
So this is a rating. Blah, blah, blah.
Hello, Anupama Garu and Johnson. If you have any questions, please
Yeah,
stop and
please,
ask.
please stop and
Uh,
yeah.
Sure. Yep.
Sure, Ravi. I'm just
yeah,
listening.
yeah. It's a Greek and Latin for me too. So I will ask so many silly questions. Prakash is my good friend, so he won't mind. So
I'm also
So
good
Prakash,
of
you're
others. So this
Prakash,
is
you're working on this language or you're learning this language at the moment?
yeah, I worked on this, but obviously when different projects, different aspects of AI I'm doing. I did, for example, in this is I mean I'm just sending this PDF. This is giving you the theory behind this recommender systems. Okay, so if you look at this, you have to actually finish the answer.
mm,
I have been doing the AI and ML right from 2018. It's a big ocean, and for BNP Paribas, I did this matching engine using reinforcement learning. That's another part of learning, which is between the AI and ML. So this recommender engine is sitting right through the ML. So what all the ML, to give a brief about ML, what it is only a predictive model. That means there will be situations where your prediction is going to be wrong. Whatever theory you use, whether it's a deep learning, whether it's uh, logistic regression, whether it's recommender systems, or whether it is a decision tree, all of them will is only a predictive model. But this reinforcement learning is basically like a gaming system. What that will do is, over a period of time, it will reorient itself and then change its course. Think about going through a maze and you have sent across a robot. The maze, the robot should go from one end to the other end. So for those kind of systems, we use reinforcement learning. A simple case could be your matching engines, right? You have sellers, you have buyers, and then you have a middleman. Say I am the middleman for the seller and for the buyer. So every time the seller is trying to sell something, I'll buy from him, and every time buyer is trying to buy something, I'll sell to him. So at the end of the day, I have to match between what I have sold and what I have bought. So these big guys, like all the banks are called the market makers, right? They are called the market makers. So they sell and they buy, and they try to take the transaction spread between the buy and sell. For example, someone is trying to sell me a tomato. I'm just making trivializing the whole thing. So someone is trying to sell me a tomato for say $1. So I will give the tomato to that seller, and then someone wants to buy a tomato. I'll give the tomato to the buyer, saying it's $1.05. So from the seller, I'll say, okay, I'll buy the tomato for $1, and I deduct my spread in that one. So I'll take a spread from the seller. I'll take the spread from buyer. Now I have, if 5% from the seller and 5% from the buyer, my net profit is 10%. See, I didn't do anything. I'm just servicing two people, two entities, and I'm making profit out of it. So that's
end
how.
of the day, you don't hold any tomato, but you have the
No,
10%
I
profit,
will
right?
hold tomatoes. I have lot of tomatoes with me. I'll
Mm,
be selling and buying these tomatoes.
mm,
So at the end of the day, what I'm going to do is that's called there is a regulation, right? There are a lot of regulations for the middlemen. What they do is, okay, hard limits is there. So the regulatory body will say, if you are market maker, you need to have some level of items with you. You can't go less. You can't be less, or you can't be more.
I see.
So they have to be within this range between more and less. less is
Yeah.
this. They
Let
have
us,
to be within range.
Prakash Garu, let us come to that formula and interpret the data there, Prakash Garu. Then
Yeah.
we will understand the numbers. Then we can correlate how it is.
Right.
Yeah, I think this is the number, right? You are trying to show. The
So
very
what
first
this
one.
is saying is,
Hmm.
I am a user, or A is a user who is giving ratings to all the items.
Yeah, average
The
rating
average.
is that.
So all the ratings, you add all the ratings, and then you divide by number of items to which you have rated. So that is the average. Okay. And this particular user A has rated I. This is R of AI. So for item I, the user A has given some rating, and the average rating is something else. So
Something
what
else,
is
yes.
the difference?
Gotcha.
What is this is called the distance. Okay.
Hmm.
How much distance is there between the present items rating and the normal average rating someone has?
Gotcha.
And this is for the you, another user you.
No, another user. Okay.
So these are
Sigma
all
sigma is like adding for all
adding.
users. It
Right.
is like
So for
okay.
all the items, no, not all the users. I is belonging to I. So I is
Oh, I see.
So for all the items, what is the distance? I mean, from the average, where is this item falling?
If he did not give any rating per item, then
Right.
Where does it follow? Yeah, RAI, what is the value RAI you take?
Right. So in such kind of scenarios, what we in our predictive models, what happens is these are all past data. So we only take for the items which the rating has done. We won't take the items for which the rating is not done.
Okay, we just ignore it. We
just
don't even.
We just ignore. So this is our.
And it is a multiplication, RAI minus RA. It's a multiplication, right?
It's a multiplication.
Okay, gotcha.
But the rankings are not going to be very different, like 0 and 100. No, you give the ratings in such a way that it is between 1 and 5 or 1 and 10 kind of thing.
Yeah, but the question is, UI is what is UI actually? U means another user.
User. U and A are users. Okay. I is the same item for which.
So U is a new unknown user, or U is unknown user, right? He's not part of the data, right? He's not part of it.
Yeah.
And then below you have a square root of RAI.
This is a simple distance. See, in our geometry, if you go coordinate geometry, the distance between 2 points is x2 minus x1 whole square.
Gotcha. So the WAU, the value will be between 0 to 1, or how it will be W.
Where?
WAU, the very first one. WAU is what we are calculating, right? Yeah. What the value? If it is weightage, okay.
It is not a prediction. Prediction
Gotcha.
will always be between 0 and 1.
See, assume that I, being a user, I rated every item as same. One rating I gave, then this W will become 0, right? Because RAI, yeah, correct. RAI minus RA is 0, so obviously W becomes 0, right? That means we ignore that guy. There is no weightage from A, or how do you interpret it? W is 0, then.
If the weight is 0, these weights play a role in the prediction. This is the prediction. Okay, P of AI.
So if W is 0 means prediction is 0 means there is nothing to predict. That guy is going to give. You don't take that guy seriously.
No. You say this. The sigma here.
Oh yeah.
So if weight is 0, it is only adding. Here, if the weight is 0, for this item, it is removed.
Gotcha.
Out of say 100 items, this weight is 0. That particular item is removed from the calculation. It's a addition. You see this?
Gotcha. Sigma, right, is a addition.
It's
Yes.
a addition. So what this is saying is, yeah, this is the weights we give
Mm.
for each weights of A versus U. That is
Mm.
a user A and user
The
U.
data with the unknown user, right? That's how the weight.
Known, I mean, known
Known
and
with the unknown. Right.
unknown in the sense that this guy has not bought a item J,
Correct. Mhm.
like that. Okay. So in the
Mm.
prediction, what you have is, this is the average rating of user A, and the U is belonging to K. K is the list of users who are similar.
I have one question, Prakash.
Yeah.
U, E, and K, right? What is the special that doesn't
No,
look like E also?
this E is not E. This is belongs to.
Belongs to, okay. U belongs to K, yeah?
U
That's,
belongs to K. Yeah. So I belongs to I.
yeah.
I belongs to I. This is a short notation.
Oh, okay. What is I and I? Okay, let us come to the first formula. What is the small I and what is the capital I?
Capital I is list of all the items.
Oh, I see. What we talked about. And each
I
sigma. Okay.
I belonging to I means an item
Gotcha.
I out of
Mm,
list of 10 items.
got it. Yeah.
Okay.
Mm,
So this is the way, this is how weight is calculated,
mm,
and this is how the probability is calculated.
mm,
Okay.
mm.
So you take the average and then you are adding the thing to this average.
Gotcha. Mm,
Okay. So usually the rating will always be between 0 and 1. It's an average rating.
gotcha.
Okay. So that's why
Anyway, probability is always between 0 and 1 only, right?
it has
So
to be.
this, it has to be, right? So
Yes.
obviously, if it is becoming closer to 1 means the probability is very high, right? For that item to be bought by
Right.
unknown user, right?
Right. Right.
So this one, okay, got it. The second formula also was good. Yeah. Anupama Garu and Johnson, are you okay? Or
Yeah,
So
Ravi.
most
Yeah, for me, everything is French now.
No, I mean, you don't think this as a formula. Think this
right.
as a simple thing. So I'll put this in a simple English. Okay.
so is
So,
this common for any scenario?
right. This is how
Okay.
the Pearson correlation coefficient is calculated like this. This is
Okay.
recommendation engine. This is how you calculate the recommendation engine. So there are
So let
different
it be any scenario, like if we are selling or predicting
Yeah,
or
means if you are, my guess is, Anupama, if you are trying to use that Pearson's formula, then you have to be abide with these two rules. That's what I think.
No, it's
So,
other way around actually. See,
mm,
what you have is you have 10 items and
mm,
you have 50 users.
mm,
Okay. So what you are trying to say is, if I want to know how many people will buy seventh item, see what is the prediction that so in your own thing, say for Albertsons, people have come and bought till yesterday. So now today what you want to do is you want to know if that particular soap that you have put in the counter, what is the one that I should put in the counter that can sell more. See, when you're paying the money to the user, to the cashier, you will pick up things that are there in the counter, say lollipop, chocolate, all those things, right? So what is the most predictable item that I should put there, so that I can give it to so that the user is going to buy it from there? That is one. The other one is profit margin. I have a lollipop that is
mm,
costing me 1 cent and I am selling it for $1. So
mm,
my profit is 100 times. 1 into 100 is 100. So 100 times profitable item, if I can sell for 1 million, then my sell 1 million times, then my whole profit is going to skyrocket like anything.
Correct.
So for those two kind of scenarios, this will work. Now, when we come to the thing, what we are saying is there are list of items. I belonging to I means there are some list of items that are there, and there is a user A and there is a user U. Okay. So we pick one item at a time, say first item. Then we say what is the rating that user has given to this item. So this comes in a movie, for example. This is more useful in movies.
Oh, I see.
Netflix movie thing, they have used this one.
Because there are like hundreds of movies and
Huh.
also thousands of users.
Right.
And then when the new user comes, what movie to show him, right?
Yeah.
Prediction.
Recommendation
Yeah,
engine.
the
Yeah.
recommendation engine is what it is
And
similar
Like
to.
the ratings are decided. So if I
Yeah, right.
like something, and okay.
The
the user
demographies and all these dimensions, Anupama Garu, it's all depends on that. And finally, if I am a new user, and then they will go through my demo. That's where they ask those questions, right? From what is your language preference, what is your movie genre preference, and all that, right? Once you answer everything,
it need
and
not be
then
new user. Okay. It need not be
yeah,
new.
with the existing user as well.
Ah.
Yeah, it can be for anybody. So it goes into the history of already whoever watched and whatever the recommend whatever the ratings they gave, and so they show us, so you might like this movie types like in our safeway.com, when you are trying to buy online, right, it will show buy it again carousels, and there are recommendations will be there right down. So all these will fall under the same category.
Not only that, this will also give you a recommendation saying that, okay, you could make this R, right? You could create this R by saying how many times did, it's a probability. You can just give
Right,
a probability.
right.
So,
So the more data, then more accurate it will become, right, Prakash? That's
right.
how it is. Okay.
So you could actually create the ratings yourself also. For instance, um, Ravi has bought Dove soap
Hmm.
for 5 months,
Hmm.
5 times consecutively.
Yeah.
So each time Ravi is shopping, Ravi is getting a Dove soap. So what
Hmm.
should be the rating? 5.
Hmm.
Because you're buying all the time Dove soap. So I can say that, okay, Ravi, next time Ravi comes, Ravi may buy Dove soap. So I give a high rating,
Hmm.
a 5.
Hmm.
So if Ravi comes next time, the Dove soap should be near the counter. So that
Yeah, correct.
a
Correct.
variation of Dove soap can be near the counter. Then you can say, Ravi, we can say, okay, I like Dove soap, but this is a new item in Dove soap. So let me try.
Correct. Correct.
Instead of one Dove soap, he will buy another Dove soap. So this rating is not necessarily the user should give. You can create that rating system also.
Got it. Yeah.
Okay. So the average is like, okay, Ravi comes to Albertsons on every time he comes, he spends 200. And these some 10 items the Ravi buys all the time. So the average rating is okay. He is going to, out of say 200 items, he is buying these 10 items. So the average rating for other 90 out of other 190, you come up with an average. So maybe incense sticks or say what do you call napkins or something like that. Ravi has bought only twice or thrice. So what is the average rating? Out of 10 times he has bought thrice. Therefore, it is 3 by 10. So 3 by 10 on napkins, 9 by 10 on the soaps, shampoo. Like that, you can you take out the average rating. And for a particular soap, what is the rating? So the average rating could be 4 out of 10 for all the items, and soap could be 9 out of 10. You have to think like that. Johnson, am I
Gotcha.
clear? So this is basically the ratings that are there, and how you have to, from a non-mathematical perspective, how you have to see this is, how far is my rating from the average rating? That is what this is saying. So if it is very close, then it is going to 0.
So it can be the value W weightage can be negative also, right? That is also possible, right? -1 to 1 is what? Or,
Right. So
okay.
average rating could be anything. The weightage could be anything, but rating can only be positive.
Rating is positive, but RAI minus RA, right? The
Could be
first one
negative.
that could be negative, right?
Negative,
Because yeah,
this could be negative, and anything multiplied with negative will become negative.
correct. Yeah.
This is more important. A lot of people don't. A lot of people overlook this particular thing. What this is saying is, for each item, I'm adding the.
Yeah, you are actually
addition.
doing a comment.
So you could
Yeah,
have.
that's a sum, right? In the calculus.
Yeah, it's a sum only sigma.
Sigma is sum. So for each item, so 10 items, for 3 items you could have negative. For 7 items you will have positive. Like that, because this is average.
Correct.
So few items will give negative, few items will give positive.
Got it.
So the negative and positive, you are adding them.
So is this all for only one item,
Yeah.
or multiple items we can use it?
So that's what I'm saying. This is for one item, and you are adding for all the items.
Yeah, sigma means you start with the chocolate and whatever user
okay.
got,
So
right? All
R of A could be one item, R of U is another item.
Yes.
Okay.
No.
But
No.
I is same. You see here, I is
I is same. So that's why I was asking. So you gave an example that Ravi would
So
buy.
about I as chocolate, A as Ravi, and U as Prakash. So
But it's the same item.
Chocolate. Yeah. Ravi.
Yeah, but when you say the second item, how
So the
are you
second
calculating?
item will be another I, that is a soap. I belong.
Okay, but you are calculating all the differences in the same sigma for all the items.
See.
Yeah, correct.
Then I say this one, right? I belonging to I. So this I is set of items.
Oh,
Say
it's a loop. Okay.
Chocolate, biscuit, soap, shampoo, all those things is a set.
Okay. It's a collection of items. Okay.
Collection. Yeah, exactly.
Okay.
So
Good.
first time I take chocolate, second time I take soap, third time I take shampoo. So how many times did Ravi buy chocolate minus the average buying of Ravi? So this tells me, in a realistic perspective, how far is my chocolate with respect to the average? How far is this item with respect to the average? That is why you are subtracting it.
Okay, and we do this prediction analysis like every day, or how? So machine learning is we
it's
are
a
telling the machine.
very good question, Anupama. Actually, you asked the next level. It's a very good question. So in our data engineering world, we have a weekly, daily predictions. So
okay.
Yeah, so that is where the huge billions of rows of data about all household users is been processed every day, daily, weekly, and monthly, and then you will actually use that data to predict for next few days, like one day.
Okay.
What is because
and this is running on Azure.
Yeah, correct. Our
Okay.
whole data pipeline, everything
You
is
can
in
run Azure or local or anything. Yeah.
local.
And is it inside the data factory or data bricks? It's in machine learning.
Yeah,
some
all these
extent?
jobs are coming from there only.
Okay.
all the data bricks.
I remember in
Yeah.
Databricks, I believe you can write in Spark and you can use it for machine learning.
That's right. That's right.
Those predictions. Oh, okay, okay. And that
Yeah.
drives our buy it again and
Correct.
other things
Exactly.
also on the website.
Exactly. Absolutely.
Okay.
So I will demonstrate.
So the
You
chance
don't
is
need a Databricks actually. You need
there is a proof
standalone.
that buy it again carousel what data to show that should be attractive for the user, right, to see. Once
Mm-hmm.
this prediction model is good, that is where they keep checking the fact checking with whether users are really going there and buying them. So that is actual data, right?
So that makes complete sense when we put it for the real use.
Yeah, correct.
Yeah, that's thanks for explaining it so nicely, Prakash.
Yeah.
Yeah, a lot of people miss this sigma.
Yeah.
And that's where the whole thing will fall. Now, if you see, the whole idea of mathematics is it has to be told in a non-mathematical way. You have to apply this on a normal scenario. Then it will be very easy. So, how far is I from my average buying? How far is I from Ravi's average buying? So, that's what this is telling. That's why you have this minus here.
Got it. You can become a good math professor.
So this is basically the distance formula. So x2 minus x1 by y2 minus y1. For each items that Ravi has bought, what is the distance? How far this is? This is called Euclidean principle.
Mm.
So we take
Finally, this WAU is nothing but a comparison between my choices with your choices, right, Prakash? A and U.
yeah, how
So
far are my choices?
how I both are. Yeah. If it
So
is zero means we are absolutely same. So it is no difference. Yeah.
right. So usually this one being zero is like what you have said. If it is falling directly into average,
Mm.
then it will become zero.
Mm.
The whole equation will become zero. Zero by anything is zero.
Correct.
But in normal circumstances, it is not
It
like
won't. It is not happens. Yeah. It
that.
does not happen.
It's a very coincidental thing
Mm.
happen. Even that's why it's a rating. It's not the number of items you are buying and I am buying. It's the
Got it.
rating that is more important. So this
Mm.
rating, you can play with this rating.
Correct. Correct.
So like this, all the weights that we get, this again is U is belonging to K. K is the similar users. So
Mm.
we both are thinking similarly, then we become similar users. So we group all the similar users, and then we come up with the product probability that I am going that a user A is going to buy I. So what is the average that user has given the rating? And for similar people, what is the difference between their rating and that particular instance of I rating? That
Mm.
means in terms of movies or items, you could take I as one item or Avatar movie, right? So what is my rating that I give to Avatar movie? But versus what is my usual rating that I give for all the movies? And assuming Ravi and Anu and me are similar uh, habit people, what is the weightage we give for a Avatar movie? So this A is one user, this U is another user. So this user U is rating Avatar on based on the average ratings. He could rate Avatar more or less. So if usually if the U is rating Avatar less, then obviously Ravi is also going to rate Avatar less because we have similarity with other items. So that's why
Got it. Yeah.
it will work. This average will always be less than 1.
Hmm. So the second formula is between the new item, a person to the item, right?
Yeah,
Probability of
yeah, yeah, yeah.
seeing that.
This is the
Based on
problem.
the historical data of weighted average, what we got it, right? So,
This one, weighted average, is what
hmm,
makes this thing.
yeah, that's right. Got it.
So all the weighted averages for all the users. This is like just an average. You are saying that, okay, my usual average and the average of all the people who are similar
Hmm,
to me.
hmm,
So that gives me the prediction. It makes sense, right? So, for
hmm,
example, Balaya fans, we are all Balaya fans,
hmm,
and for some reason I have missed Balaya movie.
hmm,
Then usually I see Balaya movie, and I will take everybody else with me or see it more when you and Anu have seen the Balaya movie
hmm.
and given a better rating.
Yeah. And once you log in, obviously it will recommend that to you, saying, boss, you missed it types, right? So it is the same. Hmm. This WAU and cos
Uh-huh.
RA, RU. Yeah.
It's a m-dimensional space and based on the cosine angle given by them.
Wow. This is another Greek and Latin, man. This one.
So this one,
Now we
yeah,
have to go back to our
The
trigonometry
school.
and everything. Yeah.
yeah, ML has been there for like from 1950 onwards. Only now we are able to see that, okay, this is useful because we have
Yeah.
so much of data and we need to predict data. And ML is only a prediction model and it is
Hmm.
not exact science.
Correct.
Unlike,
So
yeah.
this WAU equal to cos. So the first WAU is there, right? Distance between
Mm.
you and me. So the cos RA RU. How? What exactly is that formula? Cos RA RU. Uh, this is that what
What is
exactly?
the,
Yeah. I never saw this kind of number. I always
no,
saw
this is
cos
the
theta
weightage.
or cos.
This is the weight.
Okay. A and
This is a
U
vector,
weightage
right? RA
vector.
is a vector and RU is a
Uh-huh.
vector. So what
So
is a
is that average, right? Average of RA and average of RU, right? No, it is not how you look at it in this formula, second formula.
mm. So
Yeah, yeah.
this is a dimensional, RA dimensional and
Uh,
RU dimensional.
Yeah, if it
uh-huh.
is like a flat line on the top, looks like it's an average, but this is like a arrow on top of RE and
Oh,
RU.
yeah. Good
This is
observation.
called
Yes.
vector.
Oh, what is vector, man? How you arrived at that?
Vector has got direction also. It's not just a number. So for
Hmm.
example, you are watching a movie and you gave 3
Hmm.
and you have asked your friends to give more than 3.
Hmm.
So like that. So what is the emotion involved in this? That's
Hmm.
called the direction. So RA is you
Hmm.
are given rating of 3 and you asked everybody to give rating of 1.
Hmm.
So m-dimensional vector.
Hmm.
You are creating this dimensional space, okay? This space is
Hmm.
the data that you are creating.
Hmm.
And based on the past data, you are creating a m-dimensional space where
Hmm.
you are, coming up with, say, out of 10 items, you have only bought 5. You only take
Hmm.
those 5. You don't take other 5
Hmm.
like that. So this is Spearman's rank correlation and Kendall's rank correlation, maybe with adjusted cosine similarity.
Hmm.
These are all
So
papers.
this formula WAU cos vector of RA and comma vector of RU equal to this whole formula, right? So
This
do we
is
have any samples and to do this data, man? Because this is confusing. At least top ones are very explanatory that they are good, but these ones look a little bit complex, right? So
yeah. You can just do a Google and you will get a lot of things. Mean squared differences. Mean square differences is basically saying that this is the mean square difference. It's a Euclidean principle. How far are you from the average? What is the distance between them? So, for example, where this is going to work is, say, I'll tell you a simple example. Say, you have come up with an account, Ravindra account, RAVINDRA checking account. Okay. Ravindra can open another account saying REVINDRA. So what is there is at some distance between A and E. So that kind of distances is measured. So what this is going to do is this is going to amplify the distance.
I see.
This gives you amplification because it's a square. And then you are coming up with a root. So your similarity, if you guys are similar, then what will happen is you are saying, say RA1 minus RA is 2. R of UI and we both are similar, right? So we give the same rating here. So 2 square into 2 square is 4 square. And then you give a root for that. 2 square into 2 square is 2 to the power of 4, right? 2 plus 2. 2 to the power of 4, and then you do a under 2 to the power of 4 by 2 is again 2. 2 to the power of 2. So you are saying 2 is multiplied by 2, and this is the distance between my average and my rating. This is the distance between your average and your rating. You amplify the distance, and then you find the root, so that it will give you it will magnify the differences and minimize the similarities.
I see.
It will either be near 0 or it will either be very far. So if if my RA and RAI is towards 0, that means there is not this is the average rating that I give, and I give the rating similar rating to the next movie, then the whole thing will become 0. So you are creating amplification. Either it is 0 or it is high, like that.
Got it.
So Euclidean principle, that's what they say. So this is user-based correlation. Then there is item-based collaborative filtering. In this item-based collaborative filtering, for all the users what is the distance between the user rating and the average rating? And what is the distance between another item J? So this is 2 items.
This is a distance between 2 items, weightage between 2 items, right?
For the same user.
For the same user, yeah.
So,
but in the below, right? I think the top is the same, whereas the below formula was.
It is not same. It is one use for the items are different. Here, the users are different.
Correct.
Here, the items are different.
Correct. Yeah, but when you compare those two formulae, then the top one portion, sigma of U belongs to big U, and R UI minus RI into R UJ minus RJ, right? That is same, whereas the below one was different, right? Sigma square root of U to U with UI
No, it will always be same. This is Euclidean principle. So instead of items, you are using
yeah, but there is a square root of multiplying 2 sigmas, and then you are taking a square root there, and whereas here you are actually
same na 2 sigmas.
No, okay. Square root of this you can separate it out, right, in the same formula. Gotcha.
Same. It is same.
It is same. Yeah. Means they portrayed it separately, but it is same actually.
Yeah. A to the power of 1 by 2 into B to the power of 1 by 2.
I forgot all the basic mathematics. Okay, gotcha.
Yeah. When you are saying AB to the power of 1 by 2, it is A to the power of 1 by 2 into B to the power of 1 by 2. Right? So same. It is Euclidean principle, na? So principle doesn't change. You are amplifying the changes between the differences. Okay. So this is the theory. Now let's go into practice. So I sent you the list of this link where the Java is there. So here you see it is simple. Now you will be able to easily understand all these things. Okay. Number of blocks is parallelization. How many parallelization you want. So the rank is the number of latent factors in the model. Rank is a rank given to the different things. So maximum iteration is how many times you want the. So in remember in our logistic regression, what we did is we gave with different inputs what is the result coming in. We are narrowing down to the expected results versus um, given results. This is what max iteration is going to come with. So on the first our prediction model for one particular item on first iteration. Oh, guys, you are there. Okay, you are there. Okay.
Yeah, I'm there, man. I'm there. Yeah, but directly correlating this one there actually is a question, Prakash Garu. I think
no, this max is basically saying that how far is my prediction versus the reality. So this max iteration should be less. I mean, the result should be less. So then we'll come to that particular function. Remember, all the ML is trying to do is with the data, it is coming up with a proper model that can give the exact result. That's what we are trying to do. So based on the max iteration, you will get the results. This is a regularization parameter in the sense that we take off the anomalies from the system.
Got it. Yeah.
Okay. From different factors, right?
So we provide it with some configuration parameters and let it do the math, and then it will provide the recommendations. Okay.
Yes.
Yeah, that's right.
You need to know the math. That's why I went to that theory. You could actually do this without knowing the math, but then you wouldn't know what to put in this. So why you need to not have non-negative numbers could be one thing. Because it's a rating. That's why you either make it 0 or you either give it 1 or you give it 5. So this is the explicit versus implicit feedbacks. And this is the regularization parameter. So regularization parameter is basically, it is ALSWR means what it is doing is it is doing regularization on the user as well as the product, taking off the anomalies. For example, in the factors, right? For users, one user may be 25 years age, the other user may be 50 years age. How would you and the product could be one and the price can be 100, right? So when you have this kind of scenario between different columns having different numbers, what you do is you make those numbers between 0 and 1. So for example, 25 can be 0.25, 50 can be 0.5. So in that way, when you try to do the functions, you won't come up with anomalies. Everything in between 0 and 1, right? So for example, item is say 100 rupees. Then you create a benchmark of 1000. So what will happen? 100 will become 0.1. So all the items that you take into consideration, you take the maximum value, say 100, say 1000, and then divide all the individual items by that one. So the number will be between 0 and 1. That's what regularization parameter does. So if you see here, what this regularization parameter he is going to take is so this is basically a VO. So let me come back to that VO later. Let's look into this one.
These and all in which language, Prakash? This one is
this is Java.
Java. So directly in the Databricks, we can run this, right? With the data set.
We can run this even locally. That's what I'm saying. You don't need to have Databricks to run Spark. You don't need anything. It can just be a simple Java program. I'll demonstrate that now. So what I did is I just took this rating and put it here. See, this is the rating, okay? And then what I have done is I've taken these things and I'm putting that in a particular method. So do you want me to first go through these things and then run it, or you want first to run and then?
And it's already 1 hour over, Prakash. I think let us check the time.
Yeah, I was wondering as part of the next, is there going to be a next meeting?
Yeah. If you want,
maybe
do this in next meeting also. That's also.
Yeah, if you can share the links. Is there a different group chat for Spark and ML, or is it?
Yeah, I will add you to that group chat.
Okay.
Or if you want, I can put it in the opportunity thing.
Yeah, I added there also. I posted it there also. So that's how. Okay, I'm
That's
adding
for the
you
Zoom
there.
Meeting, but if you can provide some links before the meeting, we should at least go through that once. So
right.
That would help it speed it up.
Yeah. So this one,
I'm adding you to that group as well.
Okay, thank you.
When we have
thank
it,
you, Ravi.
Yeah. Sure.
But if you can reshare, I don't see any links from previous year.
Yeah. Let me reshare this.
So let me stop the meeting. Oh, meeting is stopped or what? No, right? Okay.
No. This time I took the paid purchase of this Zoom, man, because I don't like immediately in 40 minutes I have to rejoin and all, right? That is missing.
Yeah.
That is where you won't get all that disruptions.